Hello, my name is Professor Krishna Madhavan. I'm the Education Director and Co-Principal Investigator for the Network for Computational Nanotechnology. We are the group that builds nanoHUB, and we also maintain nanoHUB. And in this talk, my purpose is to introduce you to a little bit to nanoHUB, but also give you some glimpse into what we are requiring as part of this project that you're doing for Engineering 132. To give you an idea of what nanoHUB is, it is a global community of scientists and learners like you who want to learn about nanoscale modeling, simulation, and other cutting-edge research. We are in about 172 countries worldwide. Here on the graph, you see that we have activity going on all over the world at any given time during a day. People usually come online. These are scientists, learners at various levels, undergraduates, graduates, postdocs, and so on, who come in and register to do simulations, to look at lectures and tutorials, to learn new concepts. The important thing here is that we are not only worldwide, but here within the US, we are in about 50, in all of the top 50 US engineering schools, and in about 19% of the .edu domains worldwide. So what does this look like? We've been around about 12 years, and in the last 12 years, we've served several hundreds of thousands of users. But in the last year alone, we have over 325,000 users who are using nanoHUB annually. So what do these users do? We have a large number of content objects on nanoHUB. These content, in this particular case, we have over 350 different tools. The important thing to point out here about our tools is that they are very easy to use and they are very intuitive. Users contribute these tools. They come directly from research and they find their way into the classroom and into the projects and things like that. So it's very heavily used. The requirement in your project, I'll talk to you about a little bit later, about ease of use, comes from the fact that our users have come to expect our tools to be very easy and intuitive. So I'll talk a little bit more about this in a couple of minutes. In addition to these tools, we also have about 4,000 resources that have been contributed by our users. These resources come directly from research and they go into learning. That's pretty cool because what you are actually experiencing is the result of cutting-edge work that is going on in the space of nanotechnology, physics, chemistry, and so on in the classroom. That's pretty unique opportunity for you to learn. So what does nanoHUB offer for you as a learner? We have a lot of educational resources, but in particular, I'd like to point you to this resource that you see a link on over here. It's the education website. On the education website, there is a wide variety of content. There is quick introduction to nanotechnology, but also in-depth topics. But in particular, in the context of your projects, I want to point you to one area on the education page that I think you would find very useful, which is the most popular simulation tools used for education. These tools offer you some glimpse of what we mean by ease of use and intuitive, but they also offer you a link between what a mathematical model is and what a simulation is. And I'll talk to you a little bit more about this in a couple of slides. But if you are working on a project, you may want to know your partners and their end users a little bit better. And we have users from a wide range of interdisciplinary backgrounds. So if you are coming to nanoHUB, you can explore nanoHUB by topical areas or majors. For example, nanoelectronics is a topical area, but you can also look at material science, or you can look at nanobio, which is biotechnology and medicine, or you can look at physics as a topical area. There's other areas over here too. Now, once you have looked at all of this, you probably will get a good impression of what nanoHUB is. So let me talk to you a little bit about what we are expecting from you and your team as part of this project. I'm sure you've seen the project memo already. On page 2 of the memo, there are some guidelines that we indicate are sort of required of every project, and these are the dimensions along which we are going to be evaluating your work. The first guideline that we have, the first requirement, is that your projects must target a well-defined audience and present clear goals around planning PV solar panel fabrication. You probably have worked a little bit on this as part of your modeling activity, and I'm pretty sure that you have some experience looking at this in your class. But I also want to point out here that look at the phrasing over here. It's a well-defined audience and present clear goals. I'm sure that when you look at this, you can connect it back to the notions of user-centered design that you were taught in Engineering 131. You even did a project on this in the previous class. So now you have to go back and look at how principles of user-centered design will help you define a very clear audience and build towards the audience's end goals. So you have to articulate this. Now, goals 2 and 3 are sort of interrelated. Goal 2 is that your project must contain one mathematical model per team member, which means that if you have 4 members on your team, we are expecting 4 mathematical models. The focus of our evaluation is not only to see if each of the project team members has presented a model, but also that the model is of high quality. But when you put 4 or 5 or 3 or 4 models together, just remember that you have goal 1, which is that it should be very clearly focused and it should have a well-defined audience. So the models that you're presenting must have some cohesive message behind them, or a cohesive theme that addresses the end goals of your users. Now, if you have a model, the way you can interact with a model is by layering on top of it a graphical user interface, and that allows people to manipulate the parameters. I'll talk to you a little bit more about this. And so people can simulate what the model is capable of producing through a visualization. So there is a relationship between input and output variables, and your mathematical model sort of sits in between the input and output variables and does the translation, allowing you to ask what-if questions. The fourth criterion that we have over here is that your tool is highly interactive. I'll show you an example of a tool next, and you will see what we mean by highly interactive. And as I pointed out earlier in this video, the fifth criterion is easy to use and operate. This is something our end users expect a lot from us, and we expect that your projects will also have this capability. Now, let me focus in on these 2 criteria here, that is the notion of mathematical models per team member, and also that you have to build a simulation. So what do we mean by this? So here is a tool on a nanoHUB. This is called Carbon Nanotube Simulator, or CNT Bands Simulator. You can see the link where you can find this on nanoHUB. You can get an account and you can run this tool. You will see that this tool is very simply laid out. It's not about how complex you can make the visual look. It is about whether it is easy for users to accomplish the tasks that they are trying to accomplish when they are running this tool. So you see on the left-hand side that the tool has a number of parameters that users can very quickly update and change, and then they can hit the simulate button and it produces a whole bunch of results. So let me show you these 2 parameters over here, the N and M parameters, and let me focus in on that a little bit better. The N and M parameter in the scientific space is known as chirality. So when you change these parameters, what happens is that these parameters get plugged into an equation. So whenever a user changes these parameters N and M on the simulation tool, their values in the equation 12 that you see on screen here change, therefore producing very different results that you see on screen over here. On the bottom right panel of the screen, you see that when you set N to 7 and M to 7, you see a certain kind of graph, and when you have N equals 7, M equals 0, you have a different kind of graph, and the last one over here is N equals 7 and M equals 5. Essentially, what you have there is in equation 12 is a mathematical model. I also want to point out over here that we are looking for a little bit of complexity in your model, by which we mean we don't want you to build a simulator that does a simulation of y equals mx plus b. That's too simple. Our users can quickly sort of see it in their heads. We don't need that kind of a simulator. At the same time, we are not looking for a simulation that is as complex as what you see in equation 12, a model that is as complex as you see in equation 12. We are looking for something in between, and that shows a little bit of research on your part and a little bit of thinking as to how you can increase the richness of the experience for users. So essentially what you see here is that on the left side, you have a full-fledged simulator where a number of parameters are present. On the right side, I'm showing you that varying the N and M parameter actually gets plugged in to the equation number 12. Whatever values you change in N and M through the graphical user interface, they go into the equation 12, and wherever you see M and N in this equation, the values get substituted, and depending on what the values are, you see different kinds of graphs. So this is what we mean by a mathematical model being present within your graphical user interface. So the left side is the graphical user interface. The mathematical model is equation 12. And when people change the values on the left side and hit simulate, this equation is what they are talking to, and then that equation in turn gets executed, and MATLAB or any other software that you use would put out an output like you see in these graphs here. So that is what we mean by mathematical model. That is what we mean by simulation and visualization. We are really happy that you are taking on this project, and we are looking forward to what you will produce. Over the course of this semester, we'll have a number of interactions with each other. Your teaching team is your primary point of contact, but we will try to do our best to support you as you go forward in this project. So on behalf of myself, Dr. Lynn Zentner, who's the Managing Director of NCN, and also Dr. Brian Beduris, who's an Assistant Professor of Chemical Engineering, we thank you for your work on this project, and we are very much looking forward to what you will produce.